In Algebra 1, Section 5.1, we're dealing with solving systems of equations by graphing. Now, a system of equations is basically two lines that, two equations or more, but in this case we're just focusing on two. So two or more equations with two or more variables, okay? In order to find a solution is basically if I have two equations of two lines and I graph them together, where they intersect is a solution. And what that means is if I plug in that point where they intersect, it satisfies both equations. It makes both equations that we're dealing with true. So for example, number 1, tell whether 5,2 is a solution. Basically, do these two lines intersect at 5,2? And in order for us to say yes, if I plug them into both equations, they have to make both equations true. And what I mean by true is they have to have the same value on both sides. So I'm going to start by plugging it in. This is my x, this is my y. I'm going to do it to both. So 2/5, my x is 5. I don't have to rearrange the equation or anything like that, just plug them in. Minus 2 equals 0. So this is 10/5 minus 2 equals 0. And then 10/5 is 2 minus 2 equals 0. And then 2 minus 2 is 0 equals 0. Done. So this is definitely a solution on this. And what I mean is this point definitely lies on that line. Okay? Let's try the next one. 3 times x, sorry, 3 times x, which is 5, minus y, which is 2, equals 13. 3 times 5 is 15 minus 2 equals 13, and 15 minus 2 is 13 equals 13. Check. Because this lies on both points, on both lines, then yes, 5,2 is a solution. Okay? So when I am trying to find the graph, let's look at the first one. Let me graph this one first. Okay? And this one will be better on graph paper because you want to find exact. Because on this, I might not find exact because it didn't create this perfectly. But if I'm looking for an exact point where they intersect, it might be better if we use graph paper. So don't let this fool you. It might look difficult, but this m in front, because there's no number, is 1. And because there's no b, I'm assuming that it's 0. One more time, if there's no b, I can put that 0 there, because that's assuming it's starting here at the origin. It hits the y at 0. And then if there's no number in front of x, I'm assuming it's 1, and a whole number 1 over 1. So that means I go 1 over 1, 1 over 1, so on and so forth. This is my first line. My second line starts at -3, so 1, 2, 3, okay? And it means I'm going down to 1, 2, over, down to, yeah, this is over 1. So down to 1, 2, back 1. So right. Okay. So it doesn't show here, but it's supposed to hit right here. So, oh, sorry, not right here. Right here. Let me put another marker color. So right here, where they intersect, this is their solution. If I were to graph these two lines, it would intersect at 5,2. Okay? But in this case, it intersected here. So this is -1, down 1. So -1, down 1 would be -1, -1. Okay? Let's say I'm not sure. Let's say I'm not sure. So I'm gonna figure it out, because let's say you don't have graph paper and you're not sure, that's fine. Let's check. If I plug in -1 for y equals -1 for x, check for the first equation. If I do -1 for y and -2 times -1 minus 3, this will be +2 equals -1 minus 3, and then I end up with Subtracting 2 from both sides, I end up with -3 equals -3. Check. So it makes both equations true, so therefore this is in fact my solution. Okay? So on the test, you should be able to know if you got it right or wrong by just checking. I know it's an extra step, but it'll work. It'll help you out. Try page 332, numbers 3 and 6, 332, numbers 3 and 6, and I will see you in class.